Hello, Calhounians. You're going to hear me do some weird things throughout this video. In particular, say the phrase X radical 2. And I'm only doing that because I want us to remember how to do specific problems throughout the notes and the homework. So don't freak out. Just know it's part of me trying to get you to remember something. Say hi to Shipley. Shipley. Say hi. Say hi. Anyway, have fun. Okay, guys, this particular set of notes is about 45, 45, and 90 triangles. This is one of two types of special right triangles that we focus on in geometry, and more specifically, that your end of course test focuses on. What I'd like y'all to do is label what I'm about to label on this square right here, and then we'll talk about what it is that we're doing. Notice that I've labeled two of the angles 90 degrees, which makes sense given the fact that it's a square. I'm also drawing what is called a diagonal. What I'd like you guys to do is draw an arrow to that, labeling that as a diagonal, some new vocabulary that you're going to see a lot in your checkpoints. I would also like you to label the new angles that we've made, all four angles, 45, because all we've done is use the diagonal of that square to cut the square in half, and more specifically, to cut two of those 90-degree angles in half. So the note says that anytime you are solving for a missing length in a 45, 45, 90 triangle, label it like this. X radical 2. That is right. You're going to take the sides of the triangle and match it up with the different angles. Specifically, you're going to take the two sides opposite your 45-degree angles. In other words, the two legs of your right triangle, and you're going to label those two legs as X, which you're about to see me do. You are then finally going to mark the hypotenuse, the side opposite your 90-degree angle, as X radical 2. Again, anytime you see a 45, 45, 90 triangle, X radical 2. This will allow us to understand how the lengths of those sides have to relate to each other, only because we're dealing specifically with a 45, 45, 90 triangle. So in example 1, when my directions are to find the lengths of the missing sides, two of them I don't have, one of them I do have. If I understand that I have a 45, 45, 90 triangle, which I do, and we can find that missing length up top, angle C, by simply using the 180 theorem. Go ahead and highlight those sides you're trying to find. Let's take our triangle and label it
X radical 2.
And all this means, y'all, is that if I know one of my shorter legs, I know the other leg has to be congruent. Let's label side AB as 5. And let's simply label side AC as 5 radical 2. If 5 is X, and the length of AC has to be X radical 2, and 5 radical 2 is our way to go. At the top of page 2, we've got example 2. Still finding lengths of missing sides, but on this time, the length that we are given is actually the hypotenuse, that line segment AC. And so the two legs, which I'm highlighting right now, that's what we're trying to find. Now, pay very close attention to how we're going to do this. We're still going to use the fact that we have 45, 45, 90 triangle, which means
X radical 2.
the weird part about this one is that now that I'm given the x radical 2, and it looks like I have to find the x algebraically. So let's write and solve this equation. Now what I have here is x times radical 2 equals 4. Notice I said times radical 2. And I need to find the value of x. So all I have to do is treat this like a regular old equation. If multiplication is the operation, the way to cancel it out is to divide. So let's divide both sides by the very thing that I multiplied x by, the square root of 2, radical 2. However, as you guys might remember from yesterday, we cannot have a radical on the bottom of a fraction. That is math cussing. It is not okay. We cannot leave a final answer like that. Write that down underneath example 2 like I'm doing right now. And let's take that fraction and multiply it by what we need to multiply it by, radical 2 over radical 2, to get rid of that radical. Do this work and move on to example 3. Example 3 is fortunately quite a bit easier, but it's still based on the fact that I have a 45, 45, 90 triangle, which can only mean one thing.
X radical 2.
Correctamundo. Labeled the triangle, as we've been doing so far. And our algebra is actually going to be a lot easier this time. We've got the value of 3 radical 2. Kind of like example 2, we're given the hypotenuse. So let's take that hypotenuse and do something a little more creative. So I know that 3 radical 2, in this case, equals x radical 2. So now when I divide both sides by radical 2, I'm left with x by itself, equaling 3 by itself. Well, now all of a sudden, I know what x is. I know those missing sides. You're going to have some problems on your homework of this nature. Pay attention to that pattern. Reference example 3 if you see any radical 2's on your homework. And this will be a great resource to know what to do. And hopefully I'm going to have, there we go, BC up there for you. Pause the video, get this stuff down, and we'll move on to example 4. Example 4 is pretty difficult. Fortunately, it's more difficult than what you're going to see on your homework. We're putting this one on there so we can actually use some fractions to make some of the same judgments that we did on example 2 and example 3. go ahead and get the work down. You're going to need to get it down to get your homework, but we're not going to talk so much about this one on the video. Just get the work down, including my notes at the end, and you'll be good to go for your homework. Have a good night, guys. Oh, and one more thing. Almost forgot your trivia question. Hope you like my hat. Now the music you hear behind me right now is by a new group that I really like a lot. Now they put out an album this past year called Barton Hollow, and it won the Grammy Award for Best Folk Album. You guys know I'm a country guy. My question for you: who is this group? Who won the Grammy Award for Folk Album of the Year for a CD called Barton Hollow? Look it up. Learn something about good music. See you guys.